5.8 is on radical equations and inequalities. So we're going to deal with equations that have roots and how do we get rid of the equation or the roots and so on. So the steps to solving a radical equation are kind of similar to the steps to solving like an absolute value equation. So we always have to isolate. So we're going to isolate the radical. And then in order to get rid of a radical, so if I have a square root, I'm going to square both sides. If I have a cube root, I'm going to cube both sides, right? So you're going to raise both sides of the equation to the power equal to the index of the radical. So the index is that little tiny number inside the root. And then simplify and solve. So the first one, I have 5 plus the square root of x plus 1 equals 16. So I want to isolate the square root part. So I'm going to subtract 5 from both sides. Meredith, you with me? So subtract 5, subtract 5. Oops, I don't know what's happening here. So I get the square root of x plus 1 equals 11. And then I need to get rid of the square root, so the opposite of a square root is squaring, right? So I'm going to square both sides. And 11 squared is 121. So I'm going to have x plus 1 equals 121. So x is equal to 120. Done. Do we like those ones? So these are the ones that hopefully you kind of saw this at the end of Algebra 1. So most people see this. Some people don't, though, so we'll see. All right, so the next one, so I'm going to divide by 7 to isolate the root part. So when I divide by 7, I get the cube root of 5x minus 7 is equal to 12. All right, and I need to get rid of a cube root. So what do I do to both sides? Cube it. Can somebody find 12 cubed for me? I want to say it's like 1728 or something like that. What is it? It was 1728? Oh, I don't know where I pulled that from. All right, 1728. And then we're going to add the 7 over. So I get 5x equals 1735. So when we divide by 5, what do we get? 347. Thank you very much. All right. So it makes sense. So to get rid of a cube root, cube it. To get rid of a square root, square it. To get rid of a fourth root, raise it to the fourth. All right, so we're always isolating first. So this next one, I'm going to divide by 6. Do you guys want to try these? All right, so try it on your own. All right, did you guys get y equals 39? So you divide by 6 and you get 7. You square both sides to get rid of the square root. So you have y plus 10 is equal to 49. So y is equal to 39 when you subtract the 10. Feel good about that? All right, so try number 4 along with me. So we're going to isolate. So what do you think the first step is when we isolate? Yeah, add the 10. It's just like if you had like 13w minus 10. Think of the whole root as being like a variable. So if we had 13w equals 10, the first thing we would do is add the 10 over, right? Not divide by 13. So add the 10 over. And then divide by 13. Square both sides. So we get 2z squared minus 1 is equal to 4. Add the 1 over. So we have 2z squared is equal to 5. So z squared equals 5 over 2. And we take the square root of both sides. So do you remember what I said? When we take a square root, we put plus or minus. So we're taking the square root. It wasn't in the problem already, so we do plus or minus. So I get z equals plus or minus the square root of 5 over 2. Now what that means is we have plus or minus the square root of 5 all over the square root of 2. So that's bad, right? Why is that bad? Yeah, we have a square root on the denominator. So how do I fix it? Yeah, multiply by root 2 over root 2, right? Why can't I square it? I'll show you an example. So we get the square root of 10 over 2 there. It's kind of a messy 10. So you can't square it because, like, if I had the number 2/3 and I just squared it, the number 2/3 squared is 4/9. That's actually not the same number. Does that make sense? So you're changing the number completely when you're doing that. Whereas if you have something that has, like we had a square root on the bottom, when I multiply by the square root of 2 over the square root of 2, I'm not changing the number because I'm multiplying by 1, right? Square root of 2 over square root of 2 is the same as 1. So that is the same number. All right, so an extraneous solution. So extraneous, a very weird math word. It just means an extra solution. So it's an extra solution that really doesn't work if you plug it back into the original equation. So it says sometimes you cannot isolate a radical because there are 2 or more expressions with radicals. If this is the case, we isolate one radical, then we square both sides, and you're going to need a FOIL and so on. You're also going to need to check for extraneous solutions. So this happens when we have like 2 or more radicals. But it also happens with, do you guys see how this one, number 1, is different than what we've done before? Do you see how there's an extra x here? So if there's like an x in the part that you're foiling, you'll see. So I'm going to subtract the x over. So if I subtract the x over, then I have 3 minus x equals the square root of 2x minus 3. So these are different than the ones that we were doing because we didn't, when we're ready for the squaring part, we don't just have like a number on the other side. Okay? So that's kind of a red flag when you see that. It's like, oh wait, I have to check my solutions. Okay, so I have it set up like this. So I've isolated the radical. So when you isolate the radical, we still square both sides. So the right side of the equation becomes just 2x minus 3. But the left side of the equation is 3 minus x quantity squared, which remember, you cannot say that it's 9 minus x squared. Remember the freshman dream? Can't say that. So what do I need to do in that case? Yeah, I have to FOIL it out. So I'm going to write it as 3 minus x times 3 minus x. And we're going to FOIL. So when we do that, our first is 9. Our outer is negative 3x. Our inner is negative 3x. And our last is plus x squared. So it's equal to 2x minus 3. So we have x squared minus 6x plus 9 is equal to 2x minus 3. And this is an equation that has x's and x squared. So you're going to see this all the time in Algebra 2 now. So when you have x's and you have x squared terms, you have to get everything on one side of the equation and you have to factor. Okay? So you have x squared and x, so get everything on one side. So I'm going to subtract the 2x over, so I'm going to have x squared minus 8x, and I'm going to add the 3 over, so I have a plus 12 is equal to 0, and we factor. I'm writing a little note. So we have x squared and x there, so we're going to set it equal to 0 and then factor. All right, so when we factor, we're going to have x times x makes the x squared. And then we have 12 at the end, but we want our outer and inner to combine to be negative 8. So we're going to do negative 6 and negative 2. All right, do you guys see how that works? So our answers are x equals 6 and x equals 2. Okay, so we know that these are possible answers, but they may not actually be the answers. That's the frustrating thing about these ones. So you have to do one more step on these. So this is when you have like something that you had to FOIL out, right? You're going to have to check. So go back in the original. If I plug into the original, I get 3 is equal to 6 plus the square root of 2 times 6 minus 3. And if I check 2, I'm going to have 3 is equal to 2 plus the square root of 2 times 2 minus 3. We're going to check both of those. Yeah. Okay, so let's look at the first one. So 2 times 6 is going to be 12. Minus 3 is 9. Square root of 9 is 3. But notice how I have a 6 here. 6 plus 3, is that 3? No. So 6 plus 3 is not 3. Can you guys tell from the beginning why that one wasn't going to work? Yeah, because it had that 6 plus, right? And the square root part had a plus in front of it. So it's not going to work. So you can kind of eliminate choices that way. Now this one, maybe. Just because one works, or one doesn't work, doesn't mean the other one does work. So I'm going to have 3 is equal to 2 plus the square root of 4 minus 3. So square root of 1, which is 1. That one does work. So we circle that one.
Why doesn't the first one work?
Because you had 6 plus a number, and it was going to be a positive number. So 6 plus a positive number is never equal to 3. So you get 6 plus 3 is equal to 3. So we don't put a plus or minus. Is that what you're thinking? This is not a plus or minus. It's just a plus in the original problem. So there was a sign associated with it already. All right. Good? All right, next page. All right, so do you guys see how this one has 2 square roots? So these ones you definitely did not do in Algebra 1. Like the last example in this one. These are not Algebra 1 examples. These are Algebra 2 examples. All right, so in this case, we have to isolate a root. Either one. So do you guys see how this one's isolated? So we're good. So as long as you have one of them isolated, then we can start the problem. So we're going to square both sides. So the left side becomes just x minus 12, but the right side is going to be 2 minus the square root of x times itself. So we have to FOIL because we had like a plus or minus in between. All right, a binomial. So when I FOIL at the first, I'm going to have 2 times 2 is 4. 2 times negative root x is negative 2 root x. Negative root x times 2 is negative 2 root x. And negative root x times negative root x is positive x. Okay. So if we subtract the x from both sides, the x's end up going away. That's good. So we get negative 12 equals 4 minus 2 root x minus another 2 root x is going to be negative 4 root x. And now what do you think our goal is? What are we going to do now? We're going to subtract the 4, so we get negative 16 equals negative 4 root x. So do you guys see how we're isolating again? So we're trying to isolate the new root. So when you have 2 square roots in the original problem, you're going to have to isolate twice to get rid of the roots. Okay, so now I'm going to divide by negative 4. So I get 4 is equal to root x. What's your answer? 16, right? A lot of people will say 2 there because they like read it as x equals the square root of 4. It is x equals 16. It is not, because you're squaring both sides. You're not taking the square root, right? So it's just x equals 16. So we do a quick check back in the original. And if we check 16, we get the square root of 16 minus 12 is equal to 2 minus the square root of 16. So we have the square root of 4, which is 2, is equal to 2 minus 4. Does that work? It doesn't. Isn't that the saddest thing ever when you like do all that work and then what's our answer? No solution. So math, where no solution is still a solution. That's it. All right, you guys want to try number 3 on your own? I'll pause it. All right, try number 3. All right, so we're going to FOIL both sides, or not FOIL, we're going to square both sides. One side's going to be FOILed. So we're going to get y minus 1 equals whatever y minus 7 times y minus 7 is. So that involves FOIL. So we do y squared minus 7y minus inner 7y plus 49. So we get y squared minus 14y plus 49 equals the y minus 1. So did you guys all get to that point? Okay. All right, so we recognize that we have both y squared and y terms. So whenever you have y squared and y, Ryan, be nice, you're going to get everything on one side. So we're going to have 0 is equal to y squared minus 15y, right? Subtract 1y. And then add the 1, so plus 50. Which factors? So it factors into y minus 5 times y minus 10. So we get y equals 5 and y equals 10. They both do. Let's see. So if we check in the original, and we try 5, we have the square root of 5 minus 1 equals 5 minus 7. So we get the square root of 4, which is 2, is equal to, negative 2. So that one doesn't work. Yeah. So then if we try 10, we have the square root of 10 minus 1, which is 3, right? Square root of 9 is 3. And then we have 10 minus 7, which is also 3. So we get 3 equals 3, so that one does work. So sometimes both answers work, and then sometimes neither answer works. You never know. You have to check them. But usually, I mean, always it is like where it's like 2 equals negative 2 that causes it to be bad. So if you're getting like 2 equals 7, there's something really wrong there. I would go back and check. It's always like 2 equals negative 2. All right, so number 4. So I have z squared plus 7 is equal to z minus 1. So we square both sides. So we get z squared plus 7 is equal to whatever z minus 1 times itself is. So FOIL it out. So we get z squared minus 2z plus 1. Sorry, I did the outer and inner together. So it's z squared minus z minus another z plus 1. So now we have z squared plus 7 on the other side. So these are the ones I always like where you don't have to factor. Do you guys see how we don't have to factor? Yeah, those z squareds go away. We like those ones. So we get 7 is equal to negative 2z plus 1. Subtract the 1 over, we get 6 is equal to negative 2z. So z is equal to negative 3. Okay, I know right away that this is not going to work. I know. Do you guys know right away that it's not going to work? So the left side, when I plug in a negative 3, I have to get a positive answer, right? Because I don't have like a plus or minus out front. Okay, so it has to be positive. Okay, but the other side, when I plug in a negative 3 minus 1, that's a negative number. So if I do all the work and I do negative 3 squared is 9, 9 plus 7 is 16 under the square root. So square root of 16 is 4 equals negative 4. It doesn't work. So if you see that you're going to plug something in and you're going to get a negative on one side equals the square root, you know you don't have it. You know it's not right. So you can cross it out. And then our answer is no solution. All right. So let's talk about some other types of questions. Oh, I have these ones as well. Okay, so this one has like a square root within a square root. So don't let that overwhelm you. So we're just isolating with the big square root, and then we're going to isolate with the inner square root. So the first step I would do here is I would square. So when I do that, I get rid of this square root on the outside. So I get the square root of x plus 5 plus x equals 25. So then I need to isolate. So I'm going to isolate my other square root. So I'm going to subtract that x over. So I have the square root of x plus 5 is equal to 25 minus x. All right. So now we're going to multiply, or we're going to square. So on the left-hand side, I get x plus 5. And on the right side, I'm going to get 25 minus x times 25 minus x. 25 squared? Yep, 625. So 625, I'm going to have minus 25x and another minus 25x. So minus 50x. And then negative x times negative x is plus x squared. You guys all see how I got that? So I foiled. Equals x plus 5. So I say, okay, I have x's and I have x squared. Let's get everything on one side set equal to 0. You okay back there, kid? You distracting everybody?
Yes.
All right, so I'm subtracting the x, I get negative 51x. I subtract the 5 over, I get plus 620. This is a hard one to factor. It's hard to think about all the possible factors of 620. How that goes into it. 2. Some people got it. Yeah, some people got it first try. But some people are like, okay, well, 2 goes into it, and 10 goes into it, and how about 20? 20 and what? 20 and 31. Do you guys see that? That's what we want, 20 and 31. All right, so it's going to be x minus 20 and x minus 31. So we end up getting x is equal to 20 and x is equal to 31. So we're setting each of these equal to 0 and solving. So I get x minus 20 equals 0, gives me x equals 20. X minus 31 equals 0, gives me x equals 31. And then we check. So when we check, I have the square root of the square root of 20 plus 5 plus 5. I want to see if it's equal to 5. So working from the inside out, I have the square root of 20 plus 5 is 25. The square root of 25 is 5. 5 plus 5, when I take the square root, do I get 5? No. Square root of 10 is not equal to 5, right? Did I do that right? I feel like I did something wrong there. Square root of, oh, I'm plugging, yeah, 20, oh, it's 20 there. You guys could have gotten a bonus point.
20.
All right, it's 20 right there. So it's the square root of 20 plus 5 plus 20, right? X was 20, equals 5. So it was 5 plus 20 under a square root. That does make 5. So 5 is equal to 5. So x equals 20 works. And I knew because, remember, I was telling you, like, when they don't work, it's usually like 6 equals negative 6. All right, so I was like, I must have done something wrong. All right, so 31. So 31, so I have the square root of 31 plus 5 plus 31 under there. I'm seeing if that's all equal to 5. So the square root of 31 plus 5 is the square root of 36. So square root of 36 is 6. So I have 6 plus 31 under a square root is equal to 5. So if it was a negative 6, that would be like 25, right? It's a positive 6. So this one is one where they aren't exactly the same. So that's how. So I guess there can be cases where it's not like 6 equals negative 6. I lied. But the reason is from this one right here. That would have been, if that was negative 6, it would have worked out. But it can't be negative 6. It's positive 6. Because I did the square root of 36. So it was right here. Yep. All right. So we feel pretty good on this. Can we skip the next one?
Yeah.
All right. So you would just like subtract the 1 over, FOIL. Make square both sides. No. Don't you wish there was a faster way? No. There's not. I do not.
Just kidding, there's a shortcut.
All right, so a radical inequality is an inequality that contains a variable within a radical. Okay, so when solving these, you can use algebra just like normal. However, you also have to consider that there's a second part to this. So you have to consider that the radicand, the part under the square root, can't be negative. So you can't take the square root of a negative, agree? Okay, so we have to consider that. We have to say, okay, well that 2x minus 6 has to be positive, has to be greater than or equal to 0. So really you end up with 2 inequalities, and then we find where they overlap on the number line. Do you guys remember doing number lines? Like an and statement. Okay. So we're going to solve it just like normal. No big deal. You can keep your less than or equal to in the problem. We subtract the 3 over. We get 6. We square both sides. So we end up with 2x minus 6 is less than or equal to 36. So 2x is less than or equal to, add 6, so 42. So x is less than or equal to 21. But that is not the only solution. Okay. So I subtracted the 3 over, I squared both sides, added the 6 over, and divided by 2. All right, so it says, what is the second inequality? And the second inequality has to do with this part right here, the 2x minus 6. We can't have a negative under the square root. Okay, so we cannot have a negative under the square root. So that creates this inequality which says 2x minus 6 has to be positive or 0. So it has to be greater than or equal to 0. Now if it was a cube root, would I need that? No. If it's a cube root, then we're good. We can have negatives under cube roots. It's the square root. So now we solve the second inequality. So we say, okay, well 2x has to be greater than or equal to 6, so x is greater than or equal to 3. So we put both of these on the number line. So we say, okay, well we have 21 and we have 3 on our number line. And we're less than or equal to 21, but we're also greater than or equal to 3. So where are they overlapping? They're overlapping in between. So our answer should be bracket 3 to 21. So any number that you pick between 3 and 21 will make that original inequality true. But if I try something else, let's say I try 2. So go back up here. If I plug in 2, do you guys see what's bad about that? Under the square root, I have 4 minus 6. Can you take the square root of negative 2? No. Yeah, sorry, I scrolled up too fast. Right, but if I try something bigger, let's say I try 22. Then when I try 22 in here, I get 44 minus 6. 44 minus 6, 38. The square root of 38 is a little bit more than 6. A little bit more than 6 plus 3 is going to be bigger than 9. Do you guys see it? So as long as you're picking numbers between 3 and 21, you're good. But if you pick something smaller, it messes up the inside of the square root. You get a negative under a root. But if you pick something bigger, your final result is not less than or equal to 9. Okay, so that's why it has to be between those. All right, can I flip? All right, and so same thing here. So you're going to do, subtract the 4 over. So I get 3. I have the square root of 3x minus 6. I'm going to square both sides. So I get 3x minus 6 is less than 9. Add the 6 over, so I get 15. So 3x is less than 15 gives me x is less than 5. But that is not the final answer. So on these square root inequalities, you also have to say, so the second inequality deals with this inside part. So what's my second inequality? Yeah, 3x minus 6 has to be greater than or equal to 0. We can't have a negative under there. Okay, and we solve that. So we're like, okay, 3x is greater than 6, so x is greater than or equal to 2. And then we do a number line with both of those things being true. So we say we have to be greater than or equal to 2. But now our sign from the next one is less than. So what do I do here? Less than, open circle, less than 5. And they overlap in the middle, right? So our answer is bracket 2, comma 5, parenthesis. That's the answer. Okay, does that kind of make sense? You feel okay with that? Is that the end of the section? I feel like I thought I did the ones where like, maybe this is another thing, like where I have like 1/3 is equal to 2. How did I skip it? I don't know what happened. Can I do one more? Can I do those?
Yes.
All right, so what's the problem at the top of the page then? All right, so if I have something to a 1/3 power, how do you guys think I get rid of a 1/3 power? So what is a 1/3 power? It's a cube root, right? So how do I get rid of a 1/3 power? I raise it to the 3, yeah. So when we do that, 1/3 to the 3, or like something to the 1/3 to the 3, we multiply those powers. What is 1/3 times 3? 3 over 3, which is 1, right? That's what makes it go away. Does it make sense? It's just 5x plus 7 all raised to the 1, which means that it's just 5x plus 7. And then it's equal to 27. So I subtract my 7, so I get 5x equals 20. So then I get x equals 4. You do not have to check those ones. All right, and then what was the other one? Did I have one more? 2x equals 4x plus 8 raised to the 1/2. Okay, so what's a 1/2 power? It's a square root. So to get rid of a square root, I raise it to the 2. So be careful when you do 2x squared. It's not 2 and then x squared. It's 4x squared, right? 2x times 2x is 4x squared. Equals 4x plus 8. We get everything on one side, so 4x squared minus 4x minus 8 equals 0. We can pull out a 4, so x squared minus x minus 2, because they had a GCF, right? And then you can factor. So we get x minus 2 and x plus 1 equals 0.
Shouldn't it be a negative 4x squared and positive 4x?
Oh, I moved everything over here. You could do that, but I always like my x squared to be positive if possible. I don't know, I'm just weird. All right, so I get x equals 2, and I get x equals negative 1. So this one I would do a quick check because now you had a 1/2 power, and a 1/2 power is a square root. The square roots are the ones that can be weird. Cube roots, it's okay if you have like a negative under the root, right? So if you try a 2, we get 4 times 2 is 8, plus another 8 is 16. What's the square root of 16? 4. 2 times 2 is 4, so 2 works. Negative 1, does that work? No, because if you plug that in, so some of you guys are seeing it already, if you plug it into the original, you have 2 times negative 1, and you're seeing if it's equal to 4 times negative 1 plus 8 raised to the 1/2 power. So you get negative 2 equals 4 to the 1/2 power, which is the square root of 4. So we get 2 equals negative 2. That one doesn't work. So the square root ones I would still check. All right, sorry I skipped those. I don't know what happened there.